everyone. So today we are going to do Leetcode daily challenge, find and replace pattern. So before doing this question, let's go through the problem statement and then we'll check that how we are required to do this question. So now, first thing is, let me zoom it so that it is visible and now here. So in this find and replace pattern, so the question is that given a list of string words and a string pattern, return a list of words I that match the pattern. So we are given this particular list of words, right? And then we are given with a pattern which would be a string, and what we are required to return is a list of words itself, which basically maps to this particular pattern. Means the way we are encountering A, then B, then B, like that only. Either whatsoever alphabets are there, it should be there. No issues in that. But the pattern which A, B, B is following, that we need to follow. The way here first a single character is coming, then double characters are coming, right? So here in MEE, first single character is coming, then double character is coming. So in AQQ, again the same sequence follow. So like this only we are required to figure out all these strings which are there in this list of strings, and that we need to return as an answer. So this is the question. And then all this, it's written that how we are required to match it, that I have explained now. And now we need to recall that a pattern of letters is a bijection from letter to letter. Every letter maps to another letter and no two letters map to same letter. So this is the mathematical concept which we are required to use here. Basically the concept of bijection. That is, if A maps to B and then B should here map to A. Basically, if A equals to F of A, then F of A equals to A. The thing which we are using here, that's the thing here. So in that context only, we are taking that A, B, B. So these are mapping to each other. Because if we take any other word, like in A, B, B is there, so let us take D, E, Q, right? So when we map here, then we map here, it's alright. Yeah, they are unique, then it's okay. Then when B map to E, then E map to B, it's alright, they are unique. But again when B comes, right? So here if we say that B maps to Q, but Q is not mapping to B, basically that would be the same. Because in other way around, if we see that A is mapping to D, it's alright, then B is mapping to E, it's alright, but B should again map to E rather than mapping to Q. So that is the thing which we are missing here. So in this scenario, we are required to check this question. That's how it would be done. And then comes the next part. Pattern.length, basically that this particular pattern would be 20 in size. So yeah, we could, okay, let's next come to this word length, that is 50. Okay, then word of I length equals to pattern.length. So this would be the scenario. Now as per all these constraints, we could usually use up a method in which because lengths of the words are given, then there's not even given that how many words would be there. But we are required to check with the word length and the pattern length. So in that scenario, the thing would be that we need to check with the word, either the algorithm which we could map would be something like that, word into pattern, something like that. But here the thing would be the way they have used that bijection thing, right? So we would be required to check for all the words which are there and even all the lengths of those words which are there. So the solution is 50 into all the number of words which would be there. According to that, we are required to do this question for time being. But these constraints are like pretty much lower, like even, and now we are not even given with us how many words would be there. So we need to play wisely according to the word length and this pattern length also. But as per we can see here that pattern length is basically less than word length. Oh, 1 minute. So here we can see that the pattern length is basically less than the words length, and words here is basically the list which is given, means number of words which are being given to us. That is the thing, not the length of a single word. So according to that, we can do this particular question. But before doing this, now let us move to the approach that how we can do this question. So now the thing is that we are given with this pattern, right? And we need to map each word of these patterns. So the first thing which comes to mind about mapping a particular thing is that we store this particular word character by character in some data structure and then map to this particular pattern, the way we were doing there. So for that purpose, we could simply use a map, means one map in which ABC would be mapped to ABB, and another map we could use in which ABB would be mapped to ABC. Like this we can use. So let me first show you that's what I'm exactly saying. So the thing is, what we can do is that we can, through the bijection which they have mentioned, using two maps where the time complexity would be n into L and simply refers to the number of words which are there, right, and the length of each word. Yeah, but that length of word at max, how much it could go, that we don't know. Means either it could be less than pattern also or greater than pattern also, that was not given to us. So in one map we will store the word to pattern, and in the other map we will store from pattern to word. That's the thing we will be doing. And then we will compare that what char correspond to pattern's value in the second map and compare with the first. The thing would be that A, B, B, and then A, B, C. That is, this is pattern and this is word. So in this context, let us first map the pattern to the word. So now it is mapped. And then in another map, what we would be doing, we would be simply doing this A, B, and C, and then A, B, and B. So here we would be mapping word to pattern. So here we can see that A is mapped to A. So yeah, first one is correct. Then we will see B is mapped to B. Second one is correct. Then we see that B is mapped to C, and we have encountered this B earlier also, right? So now the scenario should be something like that. If we encounter it again, then it should map to the similar value only. Means it should map to the similar value which we had mapped earlier. So here the thing is that this particular B which is there, it is mapping to some other value, that is C. But it should have been mapping to B itself, because earlier we have said that B was mapping to B. So that's why here we will be returning false, and that is how this particular process would work. So this was for this first approach, but rather than using two maps, we could reduce this. Although this method time complexity is also the same, and the other method which I am now going to use, that also uses the same time complexity, but the only thing would be that rather than using two maps, now we would be using just one map, and one, just for the simplicity, we would be using Now here comes the part that in the map we would be having all this mapping, right? But in that map only we will check, does A map to the that element only which it was mapping previously, but here M and A is coming for the first time, right? So that's why it will mark as true. Then E, B and B to E. So again first time, so 2. But here it will check that E is coming for the second time. So it will check that is it mapping to the same value which it was mapping previously? Yes. So that's why overall it will return true. Now here if we see that A is mapping to A first time, so true. B is mapping to B first time, so true. Now C is mapping to B, but when we check for B, B was already mapped by someone earlier, right? So in that scenario, we will check that if B is mapping to the same value which it was mapping earlier, so it will return directly false. So this is the thing which we would be using here, but earlier we were doing all this by comparing using two maps. But now here we will be doing, rather than comparing with two maps, we would be just modifying it with a visited, we can say visited that either can use char or vector, but here we will reduce that particular by using constant number of time only, that is by using a 26 we can say it not bit, but that 26 char value would be there, means size basically we would be using, so it will reduce in terms of space, but yeah, still the time complexity would remain the same. So let me now walk you through this code. So this is how the things would be something like. So here the thing would be, we would be using for returning the answer, and then we will be giving out each word from this words into the function, and then push that if this returns true, and then at the end return answer. So here the things would be, we are using an unordered map because we don't require that it is to be in ordered manner. Only we are required to check that does it exist earlier. If it exists, then what value it is mapped to. So that's why we will be using unordered map here. Then we are using a vector bool which is of 26 size. So it is reducing the space complexity from the previous one in which we were using a map, and one more map, basically two maps were there whose size was like the number of words which are being there into their length. So now here what we would be doing, we will be going till the number of words which are being stored, right? So we will be getting each character from this particular string one, that is the number of that is the words, and then the pattern char from this other one. Now what we would be doing is this particular unordered map, if that word char already exists, the way I was saying in this particular ABC and ABB. So B was already here and here, right? So when we check for the second time, B again when we encountered that, but it was not mapping to another B, it was mapping to some other char. So that's why it will return false. So in this scenario also, here if it already exists and the mapping of word char is not equal to pattern char, because earlier it was mapped to that particular pattern char, right? So if that is the scenario, then we'll return false. Else, not else, but we'll check for the other scenario also, that if it doesn't exist earlier and in this particular vector which is being there, if in that it is not true, then in that scenario, if it is true, means it is already existing, right? So in that scenario, we will return false. That would be the thing here. Now, if both of these cases hadn't been encountered, right, then the thing would be, we'll update our this present with the pattern char. The key is the word char. Basically, now we would be doing the mapping in this particular step. And then we'll check that if at this particular pattern char, then we'll directly update it with true. And at the end we'll return true, because if it would have been false, then it would have been returned at these moments, but it hasn't returned, so we will return true. Now this is all for this particular question. And here the time complexity is basically order of so here the time complexity is basically order of n into L, and same is for the space complexity also, but here the space complexity is reduced a little bit as compared to the previous one. So here the space complexity would be because of the storage in that map, and that map storage is n into L, again the same only, because we are storing tags and the number of words according to that. So that's why. So this was all for this particular question. If there any doubt, you can comment that down in the comments. And so this was all. Thank you.